I think we'll go ahead and get started here. So welcome back, everybody. This is the stage where the expert panel will ask the consultants for clarifications and make some initial comments. So we have Terry Schick and Brian Lawhead up here, both from ABR, and then have Pete Alperts, Falk Hutman, Bob McFarland, Andy Baltensperger, and Larry Guff that will be doing the questioning, and Susan by lottery has decided that Falk gets to start. So we've got your PowerPoint ready to go. I just wanted to point out that the AV folks have given us a mouse here, so the people that were playing with the keypad and accidentally moving their slides forward, you now have a mouse to point with.
And the panel may want to just step away for a moment.
Yeah, anybody that's in the middle of the table that's getting blinded by the overhead presentations, if you want to slide off to the side for a while, that's fine.
Okay, good. Let me see, move that over here. Put that there perhaps now. That space here, just a second. Yeah, if you can just have that somewhere. Just want to show this. Okay, thank you. Okay, welcome everybody. Thank you so much. I was chosen to be the first one. So my name is Falk Hutman, and my task was to review from the technical summary the chapter 16 and 17, and then also dealing with endangered species. So I think to start out with, I think in generally, I really appreciate to be here. I'm from the university, obviously. I volunteer my time for you. And I appreciate that we can have a dialogue and a discussion. I think it's a really good thing in the framework of the Pebble Mine and in general for Alaska. Overall, I'd like to point out that there is this technical summary, but there's also actually an underlying document that you know, the EBD, and it's a little bit confusing sometimes to go back and forth. So I think the EBD is actually fairly well written, and it's very solid in many ways. It's very clear for me, so I really think this has been very well done. So this goes to the consultants. I also was quite impressed with how much survey work there has been done between 2004 and 2008, I think. So that's probably 4 years ago, but this is a lot of effort went in there. So a couple of questions that I have 2 slides here just, which I perhaps can ask you, and I don't know if we do the real interaction now or if I just go through these points. The first one, I think, in my view, is that the approach that was chosen really is a minimum approach. It's a minimum 2 impacts. Birds obviously are migratory, they're on the flyway, the international, many of them are dealing with international migrations, and so to me that looks in many cases like a micro interpretation what really would be the impact. For instance, the idea of stopover ecology, I think perhaps you can talk about it later more, but this would be an item I think we should take more into account. It's the same issue as bird diseases. Avian influenza is a big issue right now, and many diseases are actually showing up in industrial sites first. So that would be an interesting thing I think we can address there as well, including mortality and productivity studies. Specifically, I think for songbirds, that would be an interesting component to add, including bird stress, because when you add industrial development to a landscape, you have stressed animals, and this is well known as literature, it's nothing new. But anyway, I think perhaps you can talk to us more how that was done in the study. With some of the methodological issues, and that specifically, you read the summary, which again is just a summary of the CD. Some of the methods are a little bit misleading or not well described, and we come back to that later. But one question, for instance, I have is about the taxonomy. There are taxonomic databases that are out there, including ITIS. So if you deal with a taxonomic description, including subspecies, there are different standards worldwide to be used, and my question there would be, what was actually this standard? The big issue, I think, is centered around abundance. In your document, you mentioned that you have abundance as a goal. There's a lot of literature about how to actually obtain abundance estimates. There are techniques that are called distance sampling and others that are really involved and that need a lot of attention. And in the document, I cannot really see it. So this has created a lot of issues for me because it also relates to the question of survey methodology and survey design. Because distance sampling, for instance, or any of the methodologies are really sensitive to a correct design. there are other data sources out there that are also of relevance, actually. One is citizen science, eBird, for instance, GBIF, and so on. Perhaps you can talk later about how you have used those. In the document, you make reference to the breeding bird survey, but I'm not really clear how the breeding bird survey was used or whether it was used. So anyway, there are many sources out there that I think we can perhaps add, and later on you can perhaps inform us a little bit how that was done. The issue there obviously deals with some rare birds. I mean, we have 88 species, I think 88 species in the mining sites. And so, for instance, species like the white-tailed ptarmigan, which are probably not showing up by the range, but I think they're very close. So perhaps you can talk about this more in a later point. The same is true. I think tomorrow we talk more about the short-tailed albatross and about yellow-billed loon, which occur very nearby, not in the area, but certainly nearby, and certainly will be affected when the watershed is affected. So that's my question I have there. The topic about using latest world-class science. Some of you might have seen this before in some of the statements that were made. It's not really in the document here, but the claim is out there that world-class science is employed. My question then is, who are part of this scientific world-class team that are doing this work? There are methodologies and statistics that are employed that I don't see here at the moment, like such as resource selection function. We come back later to this. The whole issue of data management. We had in an earlier presentation this morning a nice introduction to data management, but I haven't seen how you have dealt with that. I think you have probably a database, but perhaps you can help us to explain a little bit more. In many of the risk assessment studies, I see PVAs to be done. That's a classic example for NEPA studies, I think, as far as I'm concerned. So the PVAs, I think, should be one component, and perhaps you can help us there, how that will be addressed or can be addressed. I think last but not least, it's pretty clear that Alaska is affected by climate change, as came up earlier too. And I think if we want to make decisions in the future with doing sustainable development in some sort, how is climate change affecting the outcome of these studies? I think that would be an interesting question. In the document, I also found a couple of strange interpretations that I couldn't really understand. Perhaps we can follow up that later. But there are certain, I would say, best professional practices, including dealing with underlying data analysis and certain type of statistics. Again, including resource selection function. I think the ranking of habitat use is probably insufficient. And so there are a couple of these type of items that I, at the moment, don't see addressed very well. Specifically when it comes to biodiversity and the maintenance of biodiversity and how ecosystem functions. These are very big topics. You see it in literature all over. However, I didn't find it in the document, and perhaps you can speak to this a little bit. Then when I go back to the technical document, I think the technical document is a little bit repetitive and imprecise in some of the wording. Now, it's clear that this one is the underlying document, but when you just read the summary, you might actually get a little bit of a misinterpretation what actually is in the document. So I think this is something that probably can be addressed fairly well. With that, there are a couple of issues I've talked and I've brought up with. We can talk more if you wish about trophic cascades, which I haven't seen implemented, and cumulative impacts. The term of cumulative impacts, I think, would be quite good. And then fragmentation, that probably will come up more when development happens. What you think about fragmentation, what is fragmentation right now as a baseline? And then also in terms of cycles, I mean, the bird surveys that were presented, are they affected by some decadal oscillation type of impacts and cycles and all these things? With that, these are just two of my slides, and I don't know where you want to proceed now. Do you want to have questions now, or do you want to follow up one-on-one or later?
It seems to me that a useful thing to do might be to go back to a couple of points where you wanted these guys to respond, and maybe we could do a little bit of that.
Sure. If you ask me personally, what interests me a lot is how you think about flyways, so impacts outside of the study area, which with birds, with migratory birds, are very eminent, of course. And then also the whole idea about abundance. If you could explain perhaps more about the abundance procedure, because that with distance sampling and so on is a big issue. Is that fair to say? Or, yeah.
Flyways, we didn't really address
So it would be this one here, I think.
flyways per se. I mean, we were looking at the local scale use of those habitats by birds in migration. So we weren't placing, at this time, the use of that area.
Could I remind you guys to speak into the microphone?
Oh, excuse me.
Yeah.
Sorry. Yeah, we weren't really, well, we're not assessing impacts, right, at this point in the ballgame. These are baseline studies, so we're not assessing migration, use of that area by migrant birds with respect to an overall flyway, for example. So that has not been done. This is simply an assessment of use of that area by migrant bird species.
So with stopover ecology sites, I mean, these are stopover sites, some of them, I assume.
Yeah, there are birds that certainly use those areas, especially in spring migration, well, in fall too.
Yeah.
Yes.
So my question again then is, I mean, how has it been adequately described? That's I think the point,
Well, we haven't done, if you're talking about detailed studies of perhaps time spent at that site relative to, in relation to other sites along that migratory pathway to evaluate the global importance of a migration stopover site, those studies haven't been done. You know, you have to mark individual birds and look at time spent in a certain area. This can be done. It's a detailed study. So no, we don't know. We don't have you know, retention time, so to speak, in these areas.
It's called turnover. Yeah, I agree. So
Yeah,
it's a turnover.
That's the term I'm looking for.
And in spring and in fall, you know, I mean, but you know, with caribou, I mean, we had telemetry data, but I mean, with birds, it can be done the same way. I mean, I'm just trying to get at this question: is there a stopover relevance for these species in the study area, and has it been addressed? That's I think the question.
I mean, I would say that it's certainly important. It's part of their migration pathway, yes. How important, I don't know. My sense is that at this point in the migration scale, given the length of the migration, depending on the species, they're relatively close to the breeding grounds already. So they probably don't have long turnover times. They may be relatively short. Depends on the weather, too. They get there and weather shuts down, they may linger longer before heading to breeding sites.
Could you speak about abundance? Because the abundance estimate is really critical for future baselines. And so the methodology that you use, what do you think, how well does the methodology really capture the true situation? Because mostly when we talk about abundance, there is actually such a thing like confidence intervals, variance is addressed. Like my feeling is that detectability and distance sampling hasn't been applied in many of the point counts, nor a research design that really addresses that. Could you help me with that?
Yes, we haven't done detectability corrections on a lot of these data. That could be done for some surveys. In some cases, we're following standardized indexing procedures is probably one way to look at it. I'm thinking about Fish and Wildlife Service breeding pair surveys for waterfowl, and that's a accepted methodology for looking at population trends over time. And these are surveys that have been done in the state for some time. So, you know, the best way to look at it is that these are indices. Are they exact measures of abundance? Probably not.
Yeah, so that was my point, because in the introduction it's clearly stated abundance in estimate, numeric estimates, and so what it really is an index. So I would just clarify that, right? Because if
absolutely.
I don't know if there's anything else we should follow up, or should we move on for the sake of time? I mean, the issue of, for instance, I have here on my list gulls. I think when we have development coming, it's pretty sure that we will have an urbanization effect in this wilderness area. So we probably get something like ravens, gulls coming in, bringing in all sorts of things. How is that? Am I correct, or what do you think about this?
Certainly could be, yes. When you have sources of food that are not there in a remote setting, species that are often predators on other birds will be attracted to the area, and you could have all sorts of ramifications of that if they're attracted and they come in large numbers.
So the baseline data that we have, I mean, that's basically sufficient then to, or is it not? I mean, let's say there would be many gulls coming in. I mean, do we really have good gull data for the study, or is that something? Nesting ravens.
I'm not sure. Are you asking whether the species assemblages are
Yeah, I mean,
correctly identified?
Yeah, I mean, can we really, let's say there will be an impact in the future or not? Can we say we have one or we don't have one when the raven nests, for instance, are changing, or when the number of gulls are changing? I mean, can we make that later on? You know, in 10 years we will say, hey, what was the baseline at that time? Do we have these data currently to go back and say these data are there?
Yes, I would say. I mean, in some cases it'd be better to have more years of data, but there are data for the number of raven nests. These were pretty thorough surveys by, identifying suitable habitats, looking for raven nests. There were also surveys for gulls. In water bodies in the mine site. So you'd have to repeat that same survey method and that same survey area in the future.
And with productivity estimates, I don't think we have productivity estimates currently, do we?
Productivity was done for the raptor survey, so yes, for ravens, not for the gull survey. That was just a nesting survey, as far as I recall.
Okay. Anything else? See, do we want to have a sequence of questions, or we come back to that, I assume so.
Yeah, so the plan is to have panel members one at a time ask questions, and then we'll have some time at the end if other things occur to people. So I can get a volunteer for going next. Yeah, come on up, Robert.
Okay. As I understand it, the task assigned to this science panel is to determine whether this environmental baseline document is adequate. And so my first question is, adequate for what? And as I was reading the data on the birds, I can say that the document is adequate as a list of species that are present. It is not adequate for any type of study that you might want to come back to from some years in the future to ask, have there been any changes? Because for the birds as a whole, all that we have is what we call presence or absence data. The bird was there or it wasn't, and that's what we know. And there's not too much that we can do with that. Now, I found that reading the report was very frustrating to me because, as was mentioned, the methodology was not clear. Because you keep talking about using point count methods, and I keep saying, why? Point count methods have been outdated for 25 or 30 years. Why are we using point count methods? We've had a much better replacement called distance sampling for a long time. I mean, the first textbook on distance sampling came out in 1993. The scientific papers preceded that. So I kept saying, don't these guys know about distance sampling? And then I get to the back and I start seeing references, and lo and behold, there's a reference to the textbook on distance sampling. So you know about distance sampling. So then the question becomes, why didn't you use it? And then everything that, it's very confusing to me, because you talk about training observers with a laser rangefinder to estimate distances, which is backwards to me. You give your observers a laser rangefinder, then they don't have to estimate distance, they measure it. And you're talking even today, you're saying that you're using a variable width point count with distance estimates methodology. But there are no estimates of population abundance. I mean, if you did that, where's the data? Where's the answers? Where's the thing that says how many birds you saw out there? And so I find that whole question is very inadequate. There are other things that come up that indicate to me that you haven't done this very often and you don't understand what you're reading about it. There are graphs in there that have plus or minus 1 standard error bar. That tells us nothing. The standard is 2 standard error bars. And then within that bar, you've got a 95% probability that your answer is somewhere in there. And if your graphs show 1 standard error and show that there are differences, if you double that line, it shows that there are no differences. You have a section in how you selected your model, and you're using the Ikike information criterion to do that. But you're using what is called the AIC criterion to do it. But you're dealing with count data, not continuous data. Therefore, AIC is inappropriate to use for that model selection. You should be using the quasi-AIC index for that data. So I don't understand why you did what you did, and I find that for the birds, and I'm not trying to say that birds are going to be the most important issue for this project. This is a water issue. This is a new road development issue, not a bird issue. But for the bird work, I find many of the studies are inadequate and disturbing. Would you like to say something about why you're using point counts?
Yes, we are using point counts. They were conducted with distance estimates. The data are there to do density estimates with distance analysis from those data. We were not given the budget to produce those for this report, but more importantly, we probably need more points to get adequate density estimates. As you know, distance estimates are really variable in the field depending upon whether the bird is seen, whether it's heard, what the observer's training level has been. So there's all sorts of variabilities. What this results in is large error bars around your density estimates. So the more points you have, the better accuracy you're going to get, the better confidence you'll have in those density estimates. So you probably need more data before you can even begin those analyses. Yes, we could have run them and we could have provided density estimates, and they probably would have been reasonable for the very common species, which are of less interest typically to regulators. That more often interested in species of conservation concern, those that are in decline, they're uncommon and rare, and you need a lot of data to be able to run adequate distance analyses to derive density estimates for uncommon species.
I agree, but I think that perhaps you need to state that, because reading the document, to me, it gives an impression of scientific rigor that when you read it closely simply is not there. And so you're saying one thing, but the numbers don't back it up. And so, and I think that as a consultant, you need to make it clear to your client that If we're doing abundance estimates on everything else, bears and caribou and the works, then state why you're not doing it for birds and why you're not just doing it for total birds. You're mixing up the kinds of birds and all other sorts of other categories which really have very little meaning. And so you state why you're not doing it that way and tell your client, if you want abundance estimates of birds, then we have to have so many samples. I agree with you. Distance sampling is very data intensive. I do it all the time. But you need to explain to the client, if this is the information that you want, then this is the way it has to be collected. And I mean, I can look at the number of point counts that you have and say, even if you collected distance measurements, you're not going to get very good estimates because you don't have enough of them. And so I just see this as a major weakness in this particular chapter.
Yeah, we don't have density estimates. We do have what we call average occurrence figures, which are the number of birds per point count. It's a simple average.
Which is very low information content.
Yeah, but it does give you an assessment, an index.
Not reliably, no. It's not a reliable.
I disagree, but it'll give you a relative abundance measurement to compare abundance among species at that site.
Roughly. Okay.
I mean, there's literature on this, scientific literature on this, and so, I mean, the literature that I'm aware of actually cites opposite. It's well proven, as to my knowledge.
All right, who would like to go next? I think we've got Andy up here and maybe switch taxa. Yeah, so, which one is yours, Andy? Where are we? Is that you?
Yeah.
Okay. I just wanted to thank Todd and the Keystone Center for allowing me to participate in this whole process, and thank Pebble for the fascinating tour the other day of the mine site. It's been a very fascinating process this whole weekend. So I was tasked with reviewing Chapter 16 and actually 41 with the endangered species. I didn't put that on the slide, but it basically deals with the terrestrial mammals. And as Todd mentioned earlier, or Milo said that my expertise is mostly with fur bearers and smaller mammals. We don't have a large mammal or ungulate expert. Nevertheless, I read through that portion of the chapter and have a few questions, more than criticisms. So I thought that why don't we just start with this slide here, that there was a thorough analysis of the game species, so the bears, moose, caribou, using standard methods, perhaps not the most rigorous or groundbreaking, but consistent with those used by Alaska Department of Fish and Game, especially the moose study, which was and the bear study, which was done in conjunction with them. And that was glad to see that detectability was addressed during those transect studies, using both the distance sampling and the multiple observers. And I guess my question is that in regards to that was whether any effort was made to correct for siteability beneath the plane, unless you have your pilot helping you with those surveys. There's an area that could be missed directly beneath the plane, and also as the plane varies with altitude, I believe it was 500 feet, and unless you maintain that precisely, then the amount of distance that you're able to view out over the to either side is going to vary with altitude of the plane. I was just wondering if you could address both of those.
Okay, I'll start with the first one. No, I won't. It was thorough. Okay, I'll start with the second one. Detectability addressed using distance sampling, multiple observers. So I assume that you're referring to the strip transects and not the line transect sampling. Okay. No, there was no effort made to correct for sightability beneath the plane. We delineate an inner width and an outer width of the strip, and typically our observers will use a GPS to, with identifiable features to use that as a check on your strip width. And we recognize that altitude variation is a problem. The aircraft had a radar altimeter, and so the pilot would attempt to stick to that, but it is challenging terrain. It's not very well suited for that. So as a check for that, we have the observers looking at the map on the GPS to try and help them identify the outer edge of the strip.
Do you have any records? Did you record your altitude over the course of the transects?
It would probably be on the GPS tracks. We didn't specifically
just be curious
address
to
that.
see how much it fluctuated.
Right.
And then also along the same lines, then, so for the caribou survey, you recorded pathways that you were able to observe from the air. I was wondering if you made any attempt to use carnivore tracks as a method of detecting some of those more elusive species.
No, we didn't do winter fur bear transects or track sampling.
Okay.
Now that it could be done in later winter. Early winter would be difficult because of the unpredictable snow. You have to time those shortly after a snowfall and get your observers out there for the surveys. But
because there are newer methods based on aerial photography and aerial videography that can be combined with distance sampling to effectively estimate population densities based on tracks in the snow. But it is very contingent on snow conditions, and you have to find the right window after a fresh snowfall where tracks can be laid down and then good weather to fly in. So it's a difficult but useful method. And I was just curious too if in the last 4 years you've been able to include the telemetry data for the caribou over the across the study area. Have you other plans, or have you included those more recent data in your analyses?
the original period for the EBD was 2004 to 2008, and so we did that analysis with the data that were available through 2008, and then when it, the document assumed a life of its own and sort of dragged on for a little while, and so we updated that to 2010, but not since then.
Okay.
At this point, we don't have plans.
There's
to
no
update.
plans at this point. Okay. And then you answered the point 5 in your presentation. I was just wondering if you could speak a little bit more about how the data from GPS collars versus VHF were incorporated in the analyses of the telemetry data, specifically with regards to accuracy, since it noted that some of the VHF locations were accurate only to a kilometer or more, and so I was just curious how you use the two types of data.
Yeah, that's actually with regard to satellite collars, PTTs.
Oh, it was, okay.
Yeah, I mean, that's the accepted accuracy of this Argos PTT satellite collars is within a kilometer. That's why we didn't try to use those location data for habitat analyses. VHF is it's variable depending on the the conditions of the survey. I mean, some of these the data are used for different purposes. When folks go out to radio track, they might be, for instance, trying to locate group locations in the summertime for an aerial photocensus. So if you fly over a large aggregation of caribou, when the biologist is tracking it, they might just punch in, all the locations for all the VHF transmitters that they're circling around. So you may not get, that was a little bit difficult to tease out. We tried to, map some of the large aggregations. It's in one of the figures. I didn't show it here today, but it's in one of the figures in the EBD. We tried to map the locations of aggregations based on the specific locations of the radio collars, and it wasn't always possible to do. We did the best we could.
Any estimates on accuracy for those locations for the
VHF? No.
General.
Yeah, I mean, it depends. Speaking from personal experience, if you got the right conditions, you can nail it right down. But other times people are, if they're just trying to figure out where in the range they are, and if the weather conditions aren't suitable for going down low for a look, you might be, within a kind of an undefined area. From the strength of the signal when you're close.
Right.
But it's really variable. And we weren't trying, we were using it on a pretty large scale to try and define the seasonal range of the herd.
Okay, and I'll just come back to this briefly. There's just a quick summary of the methods that were employed and for those game species. So there were density estimates made for both moose and bear, and then for brown bear, and then caribou, as we've been talking, use the ADFNG radio telemetry and GPS telemetry as well to examine density or kernel density distributions. The wolf, there was no specific surveys for wolf aside from incidental observations, except for examination of dens, and I was left a little bit wanting, I guess, for what was actually done for examining dens. What sort of results came out of that survey?
The wolf dens were found entirely incidentally to looking at bear dens.
So they were just marked and
yeah, people saw a hole in the
on
ground, or and when you get on the ground, you realize it's not a bear den.
Okay, so so there's that set of game species, charismatic megafauna, that had density estimates, and then there was this other set of species that were species of concern that were, in most cases, both marked or detected through other surveys and recorded as incidental observations, and then also all of these species had habitat associations made for them based on the habitat model, and I guess again I was wondering, besides the suitable habitat associations, what, if anything, was done with the incidental observations for this species, or for these species? It seemed that in most cases sample sizes were too small to do much else beyond a sort of a presence-only occurrence.
That's correct.
Okay.
Yes, they weren't a focus of the study.
Right, and that, I guess, is one of my criticisms. Then is that these are, many of them are important fur bearers, as well as important prey for fur bearers, and they deserve to be documented more than just their occurrence, but also at least a relative abundance of these species in the study area. So again, I commend the impressive and detailed habitat map construction, but I would have liked to seen it applied a little more broadly to all the species, not just those of those few. I guess it was 13 species of concern. Habitat suitability was only based on land cover, although I did see that you included some topography and soil drainage metrics in there, but I would encourage you to also include temperature and precip, as well as elevation, and then some anthropogenic variables such as proximity to human development, as well as each species sensitivity to disturbance. I think those would be valuable metrics to include in your models. Okay, I touched on number 3 there, and then number 4. I guess this was probably my biggest concern, was that how the species of concern were identified, and the document listed 5 criteria that were used, whether they were endangered, federally or state threatened or endangered species, whether they were species of special conservation concern outlined by the Natural Heritage Program, and then whether they had economic value and ecological value. And so most of the 40 species were excluded based on that they didn't fall into any of these categories. But I would like to include biodiversity value in that ecological value criteria, and biodiversity was not something that was considered as a valuable concern.
Could you explain what you mean by that?
Well, just that the number of species occurring in a region has very broad implications for the stability of ecosystems and functionality, and to presume that we know everything that the effects of the presence of any one species is replaceable by another species, I think that's a little naive, and that we need to consider just the broad diversity of all taxa as an important
So
value.
how specifically would you incorporate that in a habitat map?
Yeah, so I noticed that you do include a species diversity map in the document, but it's only done for those 13 species of concern. And I guess I would have liked to have seen that habitat model applied to all 40 species.
So
and then
include
do a species.
all the species.
Yeah, that's right. So also, fur bearers were, I felt that they were understudied. Granted, they were documented and incidentally with the other aerial surveys, but not much was done with those data. It was good to include trapping reports and sealing records, but as you mentioned in your talk, those aren't usually valuable or accurate estimates of the abundance of species. It's more reflective of the amount of effort in going out and trapping those species. And I think it's pretty well known that there's been a decline in the trapping effort targeting these species. And so rather than reporting a decline in abundance for all of those fur bearers as the data show, it would be good to conduct some sort of either tracking study or like a camera trap or hair snare study that could better estimate population abundances. That would be more useful for documenting changes over time compared to initial baseline estimates.
Yeah, I should probably comment that clearly, if we were designing, a monitoring study, we would have wanted to have done a lot more intensive work for all these species than the standard that's required for NEPA documentation. It wasn't in the realm of possibility, given our mandate and for the the priorities of the overall project, where the impacts are, where the permits are. I'm a biologist. I'm all for studying everything you can as much as you can, but there are other realities that you have to consider.
I guess I would have to agree with Bob here on this one that I mean, maybe it's not mandated by NEPA, but one of the best values to come out of these types of studies is to be able to document impacts over time, to be able to come back in 20 or 30 years after a mine has gone in and see, okay, how has biodiversity changed? Have certain species abundances, have they increased or decreased? Has toxicity levels, have they manifested themselves in wildlife or plant life? So, yeah, maybe it's not the design of NEPA, but it's still very valuable information to have. I was also a little surprised based on the effort that went into estimating bear densities that there was no studies on wolf densities. Or Dall sheep, for that matter, which is another important game species. And I was just wondering if you could speak to that a bit.
Yeah. Well, the sheep occur in Lake Clark National Park, and they're north of the area in which you could reasonably expect impacts to occur, in my view. They just don't occur in the transportation corridor study area or the mine study area. And the wolves, they're known to be present. There was a study just getting underway in Lake Clark National Park looking at they were going to be doing some wolf telemetry, and then I'm actually not sure what the current status of that study is. Again, it was a judgment call on what was required for the,
Does ADF&G have any radio-collared wolves in the area at this time?
Not to my knowledge.
It seems like that would be something that would be pretty important to examine, considering the status of the Mulchatna caribou herd. So I was just surprised that wasn't incorporated.
Just as an observation, I think it's difficult for Fish and Game to justify telemetry studies on wolves when so much of their mandate now is intensive management and removal of wolves.
Yeah, well, that's a whole nother can of worms. And then as a small mammal biologist, I was just a little concerned that the 23 species of small mammal and so that's rodents and shrews, there was no effort to detect even presences or let alone abundances of these species. And as you know, they're important prey species for a variety of fur bearers, and can be an important indicator species as well if you consider toxicity or stable isotope levels in those tissues. They're also one of the cheapest and easiest set of taxa to study. You get a couple hundred traps and throw them out at a few established grids, and you set up a very decent monitoring program. I was just surprised that there was no effort to detect these species at all, and it was their status was solely based on the habitat suitability models. Again, is it a matter of cost, or was there a reason for excluding this large set of species?
Well, there were recent inventory studies done in Lake Clark National Park and in Katmai National Park, and also on BLM lands in the area. So we did use existing information to the extent that we could, and it was fairly good recent data for that. We discussed whether or not it was worthwhile doing a small mammal study, and I've done them before. You can go out and you can kill hundreds of small mammals, and you're going to find that most of your bulls are redback bulls, and most of your shrews are masked shrews. I mean, to me, it was I'm sorry, Falk, you have different expectations of species abundance?
Yeah, I mean, tiny shrew would be an interesting example. I mean, even if you find one tiny shrew, that's interesting. So I wouldn't dismiss just based on 80% of the species that's always out there. I mean, biodiversity matters, as it was stated, right?
Sure, understood. We did discuss tiny shrew in the EBD, and again, that has some problems of its own in terms of detectability of a 1.5 gram shrew and ability to even capture them. You know, again, it's from my perspective, it was a case of priorities and where you're going with this work. You know, the expectation, the existing information indicates that tiny shrews occur pretty much statewide, and so it is a judgment call. I mean, how many hundred animals do you want to kill? I mean, we could keep filling up the museum with them.
Well, first, there's ways to detect those species without killing them. There's
right, but that's a really labor-intensive effort.
Not really.
How do you detect shrews without pitfall traps?
Shrews are the exception. You have to use pitfall traps, but there are live traps where you can detect without harming the other, 6 or 8 or 9 vole and lemming species. You detect them and mark them and release them. But it comes back to the lack of using biodiversity as a valuable proxy. And yeah, I mean, most of your animals are going to be redback voles and cinereous shrews, but you detect your bog lemming or a tiny shrew or a long-tailed vole, and you've increased the value of your survey there just by attempting to detect biodiversity.
So would your concern be satisfied by expanding the habitat evaluation to all species?
That would be the easiest way to start, yes. I would also like to see some sort of small mammal inventory, some detection survey as well, using live trapping and pitfall trapping for shrews. And then finally, I guess the incidental detections of these non-target species seems to lend themselves well to model predictions of occurrence using presence-only data instead of just sort of noting them as occurring in the study area is great, but if you wanted to know where they occur, where they should occur, using spatial models would be a helpful approach, although that has been addressed somewhat using the habitat suitability model there. Okay, I think, so yeah, I just wanted to list all of the species that were not specifically addressed in with any sort of survey effort, and it's most of the fur bearers there, as well as all of the small mammals with the exception of the tundra vole and redback vole. And you can see here some of those. I've included the Natural Heritage Program priority listings there, and it's on a scale from S1 to S5, so S1 being the most critically imperiled to S5 being stable. And you see there are a few S3, the Alaska tiny shrew is considered a vulnerable species, and then others that may occur in the study area, such as the least weasel, collared pika, little brown bat, singing vole, bog lemming, and collared lemming, as well as the water shrew, which are apparently stable, but really there's not a whole lot of data to establish what their populations are doing, and without surveying for them, it's very difficult to determine what their status is in the mine study area. So I'd just like to remind people that these guys exist, and that biodiversity is something that's worth studying. That's all I have.
Thanks. I know that Larry's going to have some questions, but I thought I'd check in with Pete first. We've had a video presentation on trace metals and contaminants. The consultant is not available. That's our fault because we didn't, let Pebble know in time. But Jane Whitsitt from Pebble is going to come here tomorrow morning to try to answer what questions she has. So I guess at this point I'd ask Pete if you have some questions or comments on kind of the wildlife side of things at this point.
Yeah, just a few. I could come up there.
Yeah, or you could do it from there, either way. Okay.
Well, my name is Pete Albers, and I'm the last one up here. And I guess one advantage of being the last one is I can say my colleagues have done a wonderful job talking about everything, and I don't have much left to say. But I would like to say that I think several points were made which are really quite important. A lot of these surveys for this type of work, and I might add this is not my specialty. I'm used to experiments, controlled experiments, and very precise writing of manuscripts that go out. And a document of this type is very long and has a totally different objective. You're just trying to characterize everything out there that you've been paid to do. And to me, it's a frustrating kind of thing to read because I'm not used to that. But be that as it may, the strength of what I have read in the wildlife section is that an awful lot of work was done. There's a lot of information there. I think there's a lot of good vegetative information that seems to be very strong. The wildlife information, I think, is spotty, and it's spotty because, as Bob McFarland mentioned, what are you going to do with it? And in the environmental risk assessment work, which we're not addressing here, that will get progressively more important. It's a good indication of presence-absence, and that's important. It's a good indication of distribution within your target area. That's important, but it's not a good indication of abundance, and that's been adequately discussed here. And one thing does come to mind, though. There's a pretty long time span between when these studies began and when they might end. And really, we don't know when they might end. We don't even know when the mine might become operational. It might be another 4 or 5 years to go through the permitting process. And by then, you're talking about a decade from the beginning of this work until you actually have construction. A lot can happen in a decade, and I don't know how this is going to be dealt with. A good thing to do or to suggest that might happen is when you get a mine plan and you know the exact footprint and you know what's going to happen with the process, then maybe you can go back and revisit what you did, tailor it, bring it in closer to the site of potential impact, and take a look at a subset of what you did before so that you've got something relevant to what's going to happen. Because right now it's just let's cover everything just in case. And that kind of concerns me, because if you don't do that and you're stuck with 10-year-old data over a huge area and just try to go into court and prove one way or the other that the effect you think you're seeing is real, it'll never happen. It just will never happen. And I've seen this with oil spills. Good experience would be the Exxon Valdez. That is the best studied oil spill in the history of oil spill studies. It's still going on. And why is it good? It's not good because everybody was prepared for it. They weren't. It's good because a lot of money and a lot of effort went into documenting what happened and what continues to happen, finding good reference sites, and both sides contributed. The oil company contributed, the resource people contributed, the state, federal government, the tribes, they were the resource people. Both sides contributed to this, and it's still going on. And it's been a long time since then. It's a lot of work. It's hard to do. You need quantitative information that will stand up to peer review and stand up in court. It's really a tough slog. But I will say one thing. Pebble has a great opportunity here to be a good example. Because if you do it right, it will be a very good example of monitoring a mine operation from beginning to end. Even if nothing happens, it's a very good exercise, and it would be a model for other mines in other situations like this. And if something does happen, you're still set to do a reasonable job of assessing whether or not The mine activity is responsible for whatever it is that you're seeing out there. But if you don't do a good job, there's plenty of examples of not doing a good job. So I see opportunity here, despite some of the shortcomings in what we've discussed. And we get into trace elements, which is really what I have a little more expertise in tomorrow. I'm not really a specialist in survey methodology, but maybe we can talk about some of the other things tomorrow. Thank you.
All right, well, actually, I think Larry's going to be the last panelist to get up and talk here. And then after Larry, I think we'll give Terry and Bob a chance to...
I'll just stay here.
Okay, sounds good.
This won't take long. Actually, I don't have any questions for Terry or Brian. I do have questions for the gentleman on the videotape.
Well, Jane Whitsitt can stand in for him tomorrow.
Okay, all right. Well, I'll defer until then.
All right, Brian, Terry, do you have some reactions at this point?
No, not really. I mean, I just say that we appreciate the effort that the reviewers have put in on this. We understand the concerns, and in the best of all possible worlds, the studies might have been designed differently if the objective was to develop a monitoring program over a number of decades. It's a permitting support study at this point, and that's the way it was focused, and that's the objective of the work that we undertook.
Terry?
I would only second that. Yeah, none of these studies were really designed as monitoring studies per se. They were designed to collect baseline data on the species that were there in the project area. So they would have been designed differently had they been monitoring studies.
Okay.
Topic for future discussion.
Yeah. And on that line, the panel at the end of the day tomorrow will have opportunity to kind of give their concluding thoughts and a summary of their recommendations and their evaluation. But I'd like to give them one last chance while we've got Brian and Terry here, if you have any further questions for them.
We'll be back tomorrow.
Okay. Okay. Charlotte, do you want to just come up here?
Yeah. I haven't figured out this thing yet. Just kind of to echo a lot of what was just said, and what I kind of stated this morning, but it was 8 hours ago and we were all very sleepy still. These are just baseline characterization studies, and future, comparative studies and benchmarking studies aren't done yet. They're out there. But that said, I appreciate all the comments that are said, because they will help us shape those better when we do that. Just it shouldn't reflect on what the consultants chose to do or didn't choose to do. They chose to help us do baseline characterization, and we'll get back to those. On the trace metals, if you do have specific questions, if you could write those down and give them to me before you leave, I'll try to contact Mark Stelgis, who is a consultant on that, tonight, and see if I can get you specific answers from him, which isn't the same as him being here to talk with you, but it's the best we can kind of do, if that would help.
Okay. Well, I want to thank Brian and Terry for letting us put you through the grinder a little bit. So we really appreciate your taking the time to answer these questions, and we'll continue the discussion tomorrow morning.